Okay, good afternoon, everybody. Thank you for staying. We're getting towards the end of the day. I want to take a slightly different tack today. A lot of the discussions have been about software, have been around displays. I want to go back to some much more basic optics. We've known for years and years that actually to get the best experience in an entertainment environment, we all sometimes need a little bit of help to see that. And the same is true in virtual reality and augmented reality. A very much overlooked area is that whole optical interface. How do we get the image from the screen or the projector into our brain? And there's a lot of technology there, a lot of psychology there that really needs to be considered. If we just think for a moment about how our brains build up a three-dimensional image of the world, our eyes are actually not that good of an optical system. You can see that very quickly. If you just sort of focus on your knuckles and keeping your eyes looking at your knuckles, try and read what the time is. It's really difficult to do. The eyes really only have a very narrow area they focus on. So in terms of building up a three-dimensional image of the world, our brains rely on over 20 different inputs there. Some of them are really simple. If I can see my right hand, but I can't see my left hand, then my right hand must be in front, the whole sort of occlusion idea. Relative size tells us about how far away something is. There's a whole series of factors that are telling our brains where things are in 3 dimensions. Now, today's headsets are dealing with about 2/3 of those cues in a not bad sort of way. But there's about 1/3 of them that are just not dealt with. Now, of course, display technologists today are working really hard to increase the field of view, increase the resolution of the screens. But of course, what are they doing? They're working really hard on those same 2/3 of the cues. There's 1/3 of them that are just missing. And that's really part of the reason that VR and AR just don't quite feel real to a lot of people a lot of the time. I'm going to give a few examples of those. Well, first of all, what we're aiming to do, of course, is to satisfy them all. So a few examples of the problems that we have today. Vergence and accommodation. Our eyes, when we look at something close up, they converge. We bring our eyes together. The other thing that happens simultaneously and stimulated by that rotation of the eyeballs is the lens in our eyes squeezes up to adjust the focus. And you can actually feel it happening. If you relax your eyes, look to the distance, and then bring it close up, you can feel the muscles in your eyes working to change the focus. Now, in today's VR headsets, we're causing the eyes to swivel left and right. We've got 2 displays. We're displaying different things on the 2 displays, so we can force the eyes to swivel, but the optics are fixed, so the focal length is not changing. So what happens when things move in 3 dimensions in a VR display? Our eyes start to move. Our brain says, it's getting closer, so I'll adjust the focus in my lens. And my lens then goes slightly out of focus. So the eye then has to adjust back. So you've got this mismatch between the convergence of the eye and the accommodated focus in the eye. That's the vergence-accommodation conflict. Now, of course, what we'd love to be able to do is introduce some extra lenses into a system such that you can stimulate the eye to operate in a normal way, such you can force the eye, as things are coming closer, to adjust the focus in the normal way. And you can do that through adjustable power lenses. A lot of people say, well, okay, this vergence-accommodation conflict, yes, it's there, but the human brain is very adaptable. We can all adapt to putting on a pair of glasses for reading, and it changes the focal condition of the eye. We get used to putting glasses on and off. That we can deal with that. But actually, when you start looking at the details, what's happening? We've done some experiments looking at reaction times, and where you have no conflict between the vergence and accommodation, at this 1 meter point here, the reaction times are much faster than when you've got that conflict between the rotation and the focus of the eyes. So that mismatch is causing a slowing in our reactions. Now, in any sort of gaming environment, that's going to be a problem. Also, it depends on the distance that you're looking at. The brain, again, can accept a certain degree of mismatch between the convergence and the focus. At large distances, more than sort of 4 or 5 meters away, the brain's actually pretty tolerant. There's a wide band, the zone of comfort, as it's called for opticians. That zone of comfort is really quite wide. The problem is, as you come closer and closer, that zone of comfort gets smaller and smaller. So getting the focus right for objects that are close up gets more and more important. So close-up tasks need to be correctly focused. Of course, what we'd love to have is the ability to see comfortably through that whole range of distances. Now, there's been some work done at Berkeley, Marty Banks' group at Berkeley, really proving that the way to fix that vergence accommodation conflict is to use adjustable focus lenses. They've looked at a whole range of different approaches, some software approaches, sort of, locally blurring images, etc., to try and recreate that. But actually, an adjustable lens design was the only way that gave a good natural feel. In augmented reality, the problem's actually similar, but actually you've got the projected image to deal with as well. I've tried several of the headsets that are out there today, and especially some of these that are providing you information out of the side, you can feel, as you're trying to look at the real world and look at the information being projected to you, your eyes are constantly having to refocus. Now, if it's just some navigation, kind of fine, okay, you have to refocus, it's just a bit uncomfortable. If you're trying to overlay a virtual image on top of the real world, it starts to get crazy if you can't get the focal plane correct, if your eye comes into focus on that virtual object at the wrong time. So just on the right-hand side here, we've got an example of what would happen in a typical fixed focus system where the focal length of the virtual image, in this case the phone there is a virtual image, that's set at 1 meter. But if you focus on your hands, holding that phone much closer than 1 meter, that phone that has a focal distance of 1 meter is going to appear out of focus. So that's kind of crazy. Your hands are in focus, but the phone is out of focus. You adjust your focus to look at something that really is a meter away. Maybe you're going to look at the, maybe you're going to look at the laptop screen here, and suddenly the mobile phone, the virtual image, comes in focus, although your hands are out of focus. So what we really want to do is adjust the focal plane, adjust the image depth through focus of the virtual image to set that at the correct distance. This focal rivalry is, I've mentioned that you can see it in headsets. Microsoft probably got the most advanced headset that's out there today, the HoloLens. If you look in their developer's guidance, they tell you, in every case, attempt to structure content to encourage users to interact 1 meter or further away. That's all about that focal rivalry. The focal distance in a HoloLens is set at about 1.5 meters, and therefore you want to put your virtual content at about the same distance so it is in focus at the right time. So we can get around it with software if we put some limitations on what we do, but look at all the use cases that we're talking about here. The real use cases for augmented reality are when it's within arm's reach. We need to be able to put virtual content at a place that you can touch it. That's where the really high-value use cases are. We want to be able to use it for augmenting maintenance processes, for augmenting surgery, where you're within arm's reach. You're in that close range where the focal plane is really very, very important. There's another reason that it would help to have adjustable focus lenses in a headset. If I look around this room, about 50% of people here are wearing glasses. Glasses are pretty uncomfortable to wear underneath a headset. I've got some bad news for those of you that are under 40. Your eyesight's going to fail. As you get older, everybody's eyesight fails. It's not a sort of bad luck thing. From the age of 45 to 55, everybody's eyesight starts to fail at short range. Everybody over the age of 50 needs glasses to help them read. If you need a different prescription for driving or reading, you've got a choice of having 2 pairs of glasses, you're constantly changing and losing the wrong pair, or you can have a bifocal or varifocal. Has anyone tried putting bifocals underneath a VR headset? I mean, that's crazy, yeah? You get a different focus at the top and the bottom. So we've got this situation where, kind of depending on where you look in the world, somewhere between 60 and 80% of us need vision correction. And headsets today, the best solution that we have today is wearing glasses underneath. Now, we can see straight away that's going to restrict the field of view. It's uncomfortable. If you have your own personal headset, and only you are going to use it, you could buy some inserts to fit in there. You could have prescription inserts. But again, look at all the use cases for VR and AR that have been talked about at this conference. It's all about training. It's all about helping people in an enterprise environment. That's a shared environment. Location-based entertainment. It's all about a shared environment. So you've got to make headsets adaptable to be used by multiple people. If we think about the insert idea, and you look at the sort of distribution of different prescriptions that are out there, there's a range of powers of about 15 diopters of power. It's not only just as simple as the power of the lens not being right, there's an astigmatism, an asymmetry in the power, and that can be at 180 different angles. So actually, if you look at the number of possible prescriptions that are out there, it's over 19,000. So the idea of having prescription inserts in a training environment and sort of everyone choosing the right insert, again, just doesn't work. We need a way of having adjustable focus lenses in a headset so each user can pick up the headset and adjust it to their own optical system. So I think that's an important message to remember. Everyone is different. We all have a different optical interface. We all need that individual tuning. Now, 5 years ago, display resolution was pretty poor. It didn't matter how good your eyesight was. Everyone had a fairly poor and blurry experience inside VR. Now, the screen resolutions are getting better and better, getting close to human eye resolution, a good human eye resolution. That's not fair if we don't make that accessible to everybody that's out there. So again, having adjustable focus lenses inside a headset gives us the ability to access that high resolution, maximizes our field of view by not having to have glasses in there, and allows also to reduce the form factor, because a lot of headsets today are allowing extra space so you can try and wear your glasses underneath. If you remove that space, you can bring the headset closer to the face, which gives you a wider field of view. So I've talked about a number of different issues here, both across the VR market and the augmented reality or mixed reality market. There's a whole vergence accommodation conflict, wearing glasses, focal rivalry. The solution that I've mentioned several times over is having adjustable focus lenses inside the headset. If we think about the different technologies that are available for adjusting the focus of a lens, there are really 3 technologies that are out there today in competition with each other. There's a fluid technology, so you move a fluid behind a membrane and inflate the membrane to change the shape of that structure to create a lens. There's a technology called Alvarez technology, which is 2 overlapping lenses, complex-shaped lenses, and it's possible with liquid crystals as well to create a lens structure. At Adlens, our company, we've looked at all of those technologies. We've discounted the LCD for a couple of reasons. One, with an LCD, you switch it on or it's off. So you kind of got 2 positions. You can't do a continuous variation unless you stack up multiple lenses, one in front of the other. And then, of course, as you start stacking up multiple lenses, you get issues with the amount of light coming through in total and the thickness of the total stack. So we've very much focused our efforts on these 2 technologies. And they're both actually working for us. They're both very, very effective. Our particular expertise is in the design of these lenses, the design of the optical systems, making sure they work when you look straight through the middle, but also making sure they work as you look left, right, up, and down as well. You minimize the distortions there. So we're working with all of those different technologies. Our concept is to fit the lenses into a headset by providing modules to the headset manufacturers. So our expertise is very much around the design of the lenses, the design of the actuation system that moves the lenses. When we work with customers, we very much like to consider the entire optical system. Typically in a headset, you've got displays or projectors, you've got possibly a number of different lenses, depending on the complexity of the headset, and then we want to add our lenses in there as well. So if we just try and add ours as a bolt-on, you very quickly get into issues of space and the space that's required there. So we work with headset manufacturers to start combining different elements of the optical system. So to link together the different lenses, making sure that as we introduce our lenses into the headset, we're taking the minimum amount of space, and a lot of our engineering effort at the moment is around minimizing the space claim of the lens assembly and the motor assembly, minimizing the power consumption, minimizing the weight, all of those things that we know are important in a headset design. It's just an example of some lenses. We don't restrict the field of view. We can make the lenses really quite large. You can see there's change of magnification, change of focus happening there in the lenses. So really just to wrap up and summarize, we believe adjustable focus lenses are going to be a necessary component of headsets of the future. They're going to be necessary in both VR and AR type environments. There's different problems, there are multiple problems that need fixing. By introducing adjustable lenses, they're going to make headsets much more immersive, much more accessible for people to use, much more comfortable for people to use. And again, at the end of the day, that's what we're all trying to do. We're trying to make headsets that people can use longer and longer. A number of times I've had conversations with headset manufacturers, and I say to them, are you aware of the Vergence accommodation conflict? No, never heard of it. And then I ask them, well, okay, how long do your users tend to wear a headset for? Oh, well, we limit it to half an hour because users get uncomfortable after half an hour. They get eye strain. Okay, you know what the Vergence accommodation conflict is. So it's absolutely necessary to make headsets usable for long periods of time. I mentioned the fact that all of our eyes fail with time as well. Our long-term roadmap as a business is actually to apply this technology not only to the VR and AR world, but actually to the eyewear market as well. If we can have adjustable focus lenses inside a pair of glasses, we then fix that issue that I was talking about before of having to have two pairs of glasses or having to wear bifocals. You could have one pair of glasses that knows where you're looking and then switches the focus automatically. So that's kind of on our long-range roadmap as a business, but it will be the same technology that we're introducing in there. So that's the end of my talk. I'm happy to answer any questions. Thank you very much for your attention.